Hello and welcome to Calc II. Today we're going to be looking at 5.4, 5.5, and then 5.6. This is going to be like a review of integration. We start off with the fundamental theorem of calculus, part 1, which basically tells us that if we have a derivative of an integral, that the derivative will cancel with the integral of the function. And what happens is we end up replacing the variable with the variable of integration here with x. Okay, so x goes in there, and that becomes our new function. So derivative of integral cancel, we're left with the function. We replace the original variable with the variable in the integral. Okay, so let's take a look at some examples. There are some tweaks to that rule, but we're going to discuss it as we go through the examples. Okay, so for the first part, we see that we're going to find dy dx of our integral. Okay, so if our integral is from a to x of t cubed plus 1 with respect to t, we take the derivative of the integral, and that will cancel. So that will give us x cubed plus 1. Okay, and that would be it for part A. Let's take a look at part B. Now notice in part B, the variable is the lower bound of integration. So what we're going to do is we're going to switch the bound. We're going to move the x to the top, and we'll move the 5 down to the bottom. Now remember, anytime we switch the limits of integration, we apply a negative sign in the front. Okay, so this is really doing the negative integral from 5 to x of 3t sine t dt. Okay, so now if we take the derivative of this, then we'll be ending up with negative, and then replace the t's with x's. So negative 3x sine x. Okay, and then that would be the final answer. Okay, let's take a look at C. In C, here's a wrinkle to it. So we have we're going to take the derivative of the integral. Now notice the upper bound on the integral is an x squared. It's not a simple variable. So when it's an x squared, we're going to end up using property of the chain rule to finish off the problem. Okay, so when we do this, we're going to replace the t with x squared. Okay, so we'll have cosine of x squared, and then we multiply by the derivative of x squared. So it's like taking the chain rule. Okay, so when we multiply it by the derivative of x squared, derivative of x squared is 2x, and so to simplify it a little bit, we would just say 2x times cosine of x squared. Okay. Alright, let's look at D. Okay, D is going to be similar to B, where we're going to have to switch the bounds on the integration. So as we do that, we're going to introduce the negative. So we have the 1 plus 3x squared come up top. The 4 goes down to the bottom. And we have 1 over 2 plus e to the t dt. Okay, so now let's finish off the problem. As we take the derivative of the integral, of course, derivative integral cancels. We still have the negative there. We'll have 1 over 2 plus e to the t. Now t is what we're going to replace with. So we're going to have 1 plus 3x squared. Okay, and now because we no longer have an x there, we have this function, if you will, 1 plus 3x squared. We multiply by the derivative of that function. Okay, so the derivative of that function would be, well, the derivative of 1 is 0, but the derivative of 3x squared is 6x. Okay, so to finish it off, we simplify it a little bit. We'll bring the 6x and move it to the top. We'll put the negative there. That's negative 6x over 2 plus e to the 1 plus 3x squared. Okay. Okay. Let's take a look at the other theorem that we should just briefly mention. This is a theorem that many students are familiar with, the fundamental theorem of calculus part 2. This is what a lot of people call the evaluation theorem. So when we're looking for the area under a curve, right, we would often have, let's say this is our function, and we have a fixed interval from a to b. Okay, and we're looking for the area underneath the curve. Right, this is what we would do. We would integrate this function, and then we would evaluate the upper bound and the lower bound, and then that will give us the area underneath the curve. Okay, let's take a look at indefinite integrals and the substitution method. 5.5. Find the integral. Okay, and we have this integral here, x cubed plus x raised to the 5th power times 3x squared plus 1 with respect to x. Okay, so with this one we have to figure out what is really the main function that's being integrated, and what is the derivative of that function. Okay, so if we look at this, the 3x squared plus 1, that's the direct derivative of x cubed plus x. Okay, so that tells us that our u is going to be x cubed plus x. Okay, so we have u equal to that, and that means if we do du, derivative of u would be 3x squared plus 1. Okay, and then that would be, of course, with respect to x. Okay, so what we have here is, if we integrate this, we have u to the 5th power, and then the 3x squared plus 1 dx, that's our du. So we have integral of u to the 5th du. So when we go to integrate this, we're integrating u, so we increase the power by 1, so it becomes u to the 6th divided by 6 plus c. Okay, and then what we do is we substitute back in. So we know that this is going to become 1/6 here. And our u, substitute back in, would be x cubed plus x to the 6th plus c. And that would be it. Okay. Let's take a look at another one. Find the integral of square root of 2x plus 1 with respect to x. So we say that we have u equal to 2x plus 1. Du would be, if we take the derivative of 2x plus 1, would be 2 dx. Okay, so we notice here that we don't have a 2 on the outside of our square root, right? So we do have dx. So to get the dx alone, we divide by 2, so that means we have 1/2 du. Okay, so we have integral of u. I'm going to use the 1/2 power here, u to the 1/2, and I have a 1/2 du Okay, the 1/2 I'm going to pull outside of the integral. So 1/2 integral u to the 1/2 du. Now I can integrate this. So I have 1/2. If I increase by 1, that makes it u to the 3/2 divided by 3/2. Okay, now what I could do here is instead of dividing by 3/2, I multiply by 2/3, right? Dividing by a fraction is the same as multiplying by its reciprocal. So that means I can multiply by 2/3. Okay, so now when I multiply these, I can cancel the 2's, right? The 2 in the numerator, 2 in the denominator, so I'm left with 1/3. So I have 1/3. And I'm going to plug back in place of u. Okay, my u was 2x plus 1. So I have 1/3 of 2x plus 1 to the 3/2 power plus c. And that would be my final answer. Okay, let's take a look at another problem. Here we have a similar problem with a slight twist to it. So we got the square root of x times the square root of 2x plus 1 with respect to x. Okay, I'm going to say u is equal to 2x plus 1. du is 2 dx. Now notice I have an extra x here in the problem. I don't have that with my du. So what I could do then is I'm going to rewrite my original u substitution problem here, the u, and I'm going to rewrite it and figure out what it is in terms of x. Okay, so if I have that, let me put that down here, u equals 2x plus 1, and if I solve this for x, subtract 1 from both sides, I have u minus 1 equals 2x divided by 2. So x is equal to u minus 1 over 2. Okay, so that means I could do the substitution now. Now keep in mind I don't have the 2 dx in here, so I will do du over 2 is equal to dx, or 1/2 du is equal to dx. Okay, so when I integrate, I'm going to replace x. X is u minus 1 over 2. I could do 1/2 u minus 1. And I have u, square root of u, so I'm going to say u to the 1/2. And then I have my dx. My dx is 1/2 du. Okay, so I have a 1/2 and a 1/2. That's 1/4. Bring the 1/4 out. And then I have u minus 1 times u to the 1/2 du. Okay, so next, what I could do is I could distribute the u to the 1/2 into the parentheses. Okay, so that gives me u to the 1/2 minus, well, u to the 1/2 times u, let me fix that, u to the 1/2 times u, that would be, u is 1, so we add that, that would be 3/2, minus u to the 1/2 times 1 is u to the 1/2, du. Okay, now from this step we could integrate. So we have 1/4 u to the 3/2. When we integrate that, we add another 1. That becomes u to the 5/2 over 5/2. Instead of dividing by 5/2, we could say times 2/5. Okay, similar thing with the u to the 1/2. Add 1, that's like 2/2, so it becomes u to the 3/2 divided by 3/2, which is the same as multiplying by 2/3. Okay, so now that we did that, we can go through and distribute the 1/4. So when we do the 1/4 times 2/5, the 2 and the 4 can cancel, so we have 1/10 u to the 5/2 minus 1/4 times 2/3, that would be 1/6 u to the 3/2. And now just replace u, substitute back in what u was. U was 2x plus 1. So we have 1/10 of 2x plus 1 to the 5/2 minus 1/6 of 2x plus 1 to the 3/2 plus c. And that would be the final answer. Okay. So I'm going to pause this here. We're going to pick it up with our second part, part 2. But this was just a brief review of 5.4 and 5.5. Okay, we'll see you in the next video.